Okay, I'm Haziq. So let's start with some introduction about the research. So phosphorus is an important macronutrient that required for plant growth and development. It is commonly used in agriculture as a phosphate nutrient. However, under high rainfall conditions, the phosphate can be leached from the soil, which is leading to the nutrient loss and environmental problems such as the water pollution. So here are the problem statement that led us to do the research that we conduct, which is the conventional phosphate fertilizer such as Christmas Island rock phosphate that we use may release rapidly, especially under high rainfall conditions. This will increase the risk of phosphate leaching. However, there are limited studies comparing conventional rock phosphate and slow release fertilizer under stimulated rainfall conditions in soil system. The objective of this study is to study and compare the phosphate leaching between Christmas Island rock phosphate and the slow release fertilizer. This purpose is to investigate the effect of the different simulated rainfall volumes on phosphate leaching in soil. So the hypothesis that we come out with is that the slow release fertilizer exhibits lower phosphate leaching compared to conventional rock phosphate due to its controlled nutrient release mechanism. It is also expected that increasing rainfall volume will increase the phosphate leaching from soil.
Previous studies have reported that rainfall intensity significantly increased phosphate leaching from agricultural soils. In addition, fertilizer formulations plays an important role in controlling phosphate release, where slow-release fertilizers have been shown to reduce phosphorus loss. However, direct comparisons between conventional rock phosphate and slow-release fertilizer under simulated rainfall conditions remains limited. For the methodology part, the experiment was carried out using a soil column leaching setup. First, soil columns were prepared using recycled 1.5 liter plastic bottles. A carton layer was placed at the bottom to prevent soil loss, followed by 100 grams of dry and sieved topsoils. Next, two types of fertilizer were applied, which are Christmas Island rock phosphate and Vesti Grow slow release fertilizer. Both fertilizers were applied at the same phosphate level to ensure a fair comparison. Simulated rainfall was then applied using distilled water at increasing volumes of 100 to 500 milliliters. After each rainfall volume, the leachate was collected from the bottom of the soil column. The phosphate concentration in the leachate was analyzed using a UV visible spectrophotometer. The concentration obtained was later used to calculate the mass of phosphate leached and the percentage of phosphate leaching. This calibration curve shows a strong linear relationship between adsorbent and phosphate concentration with an R-squared value of 0.998. This indicates that the UV visible spectrophotometry method used is reliable and suitable for determining phosphate concentration in the leachate samples. This graph shows the percentage of phosphate leached at different rainfall volumes. Phosphate leaching increased with increasing rainfall volume for both fertilizers. However, CIRP consistently exhibit higher phosphate leaching compared to the slow-release fertilizer across all rainfall volumes. To further explain these results and discuss the differences observed between the two fertilizers, I will now hand over the presentation to my group member Haziq.
Based on the result, we discussed that Christmas Island rock phosphate constantly show higher phosphate leaching compared to slow release fertilizer SRP. This is due to the controlled release coating in the system of slow release fertilizer, which slow down the phosphate dissolution. Additionally, phosphate leaching increase with higher rainfall volume as water flow enhance phosphate movement towards the soil pores.
In conclusions, the objective of this study was successfully achieved. The results show that slow-release fertilizer reduce phosphate leaching compared to conventional fertilizer, while higher rainfall volume increase phosphate loss for food fertilizer.
So based on this study, we recommend for the future field studies under natural rainfall condition should be conducted. Long-term leaching behavior and effect of different soil types on phosphate leaching can also be investigated, as the result may come different.